So let's say they give you a diagram of an object in circular motion, and they say the object's under non-uniform circular motion. And an example is like a roller coaster. And they ask you, what is a tan? Would you know how to answer that? If not, continue watching this video. First, what does it mean if an object is no longer in uniform circular motion? The main consequence of this is that the speed of the object is no longer constant. And there's some key takeaways from that. When speed is no longer constant, we still have a rad equal to v squared over r. And a rad still always points towards the center of the circle. But the one key takeaway is that a rad is no longer constant. A rad's constantly changing in value, and a rad's maximum when the velocity is maximum. Additionally, we also have an acceleration that is pointing parallel to the velocity vector, since the velocity is changing in magnitude. This acceleration is similar to 1D acceleration motion. And so a parallel is equal to a tan. And we call it a tan because tan stands for tangential, and the vector is always pointing tangent to the circle. The equation for this is the change in velocity over change in time. So this is like a standard 1D acceleration equation. How does this motion look? So at the top of the circle, the velocity vector is the smallest, and the acceleration rad is pointing down. This makes sense because physically, if you were following motion in the circle, gravity is going to be slowing it down from the bottom to the top. As it goes up, the circle to the top is going to be slowing down all the way through. So that would make sense for the velocity to be the smallest there. Then as it moves counterclockwise, velocity starts to speed up, and the acceleration radial increases, but also it picks up a tangential acceleration as well, pointing in the same direction as v. And as it continues counterclockwise to the bottom of the motion, that's when velocity is maximum, which means that the acceleration in the radial direction is also maximum. And this makes sense for the velocity to be maximum at the bottom because the gravity is going to be helping it move faster throughout the motion to the bottom, versus the next half, the gravity is going to be in the opposite direction to it. So as it continues to move counterclockwise up the circle, the velocity is slowing down. A rad is still pointing towards the center, but the tangential acceleration is pointing in the opposite direction to v. And a tan is pointing in the opposite direction because v is slowing down. And this makes sense because if we look at the equation here, the change in velocity over change in time is going to be negative because v2 is going to be less than v1, meaning it's slowing down. So v2 minus v1 is going to give a negative value. Therefore, acceleration tangential is going to be negative, pointing opposite.